Hello everyone. So in my last video, I have explained what is RAG architecture and what problem it solves on top of generative approaches. Okay. So today, what I'm going to do basically, I'm going to implement this whole architecture using a LangChain, of course. Okay. And then we'll see at the end, we'll be able to build this nice personal Gen AI assistant. Okay. So here, if I show you, I have utilized this blog basically, so this data set, everything around adversarial attacks in LLMs. Okay, so this is the data set I'm going to train because the idea behind RAG architecture is you can easily and in very less time you can train. You should not name as train because in RAG we don't train really, but it's a kind of retrieval based approach. So that's where in our custom or private data set, we create embeddings, and from there we extract the vectors and store in VectorDB, and from there we run some similarities algorithms which will give us the most similar documents, and on top of that, including the prompt, then we send to the LLM models, and then we get the response. So in a nutshell, this is whole what we have studied in my last video. Okay, so that's what I have created here. So no worries, I'm going to tell you everything how I have built this, but let me give you a demo like how it will work. So as I said, like I have trained this Gen AI assistant on adversarial attack. So let's ask this, like, what is adversarial attack? Okay, so let me see like if it is able to answer us or not. Okay, so now I hit enter, and then it is kind of generating the response. And behind the scene, I have used Streamlit application to build this nice UI. Okay, so that also I'm going to explain, so nothing to worry. So now you see here, it has generated this nice response. Okay, and this is coming from that particular data set, like which we have used as a custom data set. Okay, not from the whole set of information LLM contains. And now suppose you want to ask something else around adversarial attacks, like how adversarial attacks impact uh, output of the models, right? Suppose this is our question. Let's ask further and see here. It is answer is getting generated, right? So if you wait for a second, then you will see the answer. Now you see here how adversarial attack impact output of the model. Then it is saying can impact the output of model by triggering them to produce undesired results, and you can read later, right? So this is the whole thing. So basically this is what I'm going to build. So now let's start building this. Okay, so now you got the idea at what we are going to achieve or learn at the end of this video. Okay, so let me start one by one. So what I'm going to do basically, so here I'm opening this Visual Studio, so VS Code, basically Visual Studio Code. Okay, and that's where I'm going to code everything. So here what I have done basically, I have created this empty folder. So what you can also do, if you open this VS Code, then what you can do basically, you can come here and open folder, and here you will you can navigate to the directory where you want to create this project. So I'm here in my Git repository, and then inside that I have created a new folder, this blank folder. Okay, you can do this new folder and you can create this one. Okay, so I'm canceling because I have already created, and inside that we need certain files. For example, there will be app.py main file. Okay, and then some more files will be there. So I'll be telling one by one. Okay, so first of all, we need to create one virtual environment, so that what will happen, it will not conflict with other dependencies installed in my system. Okay, so it's always good to work inside a virtual environment. So what I'm going to do basically, Python and with venv, maybe RAG environment. Okay, I'm creating a virtual environment with the name of RAG. Okay, and now if I hit enter, then it will just create a virtual environment here. Now you see here, so just monitor this left side panel here. Whatever I'm doing, whatever work I'm doing, corresponding files are getting generated. Okay, so this RAG environment files folder got created, and inside that there are different folders. Okay, and now basically what we need to do, we need to activate this environment. So how you can activate basically, so with start with dot and just type this. So I'm inside my Mac machine, so that's where this is the format. This is the line to activate the environment. If you are inside your Windows machine, don't include this dot. Rest everything will work. So basically, For Windows machine, what you need to do basically, for example, venv slash script plus activate. So this is the command which will work in Windows machine, not okay. And for Linux, you can start with source and then venv, and then remaining will be same. Okay, so you can do some different thing. Anyway, I have a separate video for the same, like how to create and activate virtual environment. You can refer that as well. But for now, we'll be using this. So RAG environment. So this virtual environment got created. Now, whatever libraries I will be installing, it will get installed inside this virtual environment, and it will not get conflicted with my system dependencies. Okay, so that's good. So now what I'm going to do basically, I need to install certain libraries. Okay, for example, LangChain, Streamlit, and one of the VectorDB, all those things. Okay, so let me create a requirement.txt. Okay, and here we can mention like what are the libraries I need basically. So I have already noted down some of the libraries which I will paste here. So let me explain one by one. So ChromaDB will help you to utilize the VectorDB functionalities. Okay, so there are different VectorDB. For example, Pinecone is one, ChromaDB is one, FISS is one, and there are different. Okay, I'm using ChromaDB. Another one is like LangChain. So LangChain is like they have created a framework to utilize APIs against large language models. Okay, and OpenAI, basically OpenAI, I'll be using to use one of the OpenAI large language models, and then Python dot environment to load the some, for example, we need a secret key and all those things, right? So we'll just load using dot environment. And then BS for this is nothing but the beautiful SOAP library, so which is used to extract the text. Tick token is like to generate the token, a Streamlit for that UI building, and a Streamlit chat. So we'll be using to give a chat interface, and then Hugging Face hub. So this is nothing but basically the prompt repository. Okay, so how to generate and create the prompt. So you can customize, you can generate your custom prompt, or you can use the inbuilt one. Okay, so but don't worry, in my next video I'll be creating one separate video for explaining the whole thing around prompt. Okay, so for now, you just understand this is the hub. From there, you can extract the prompt. Okay, so these are the things we are going to install. So now you can install pip install. Okay, so whatever you have mentioned in requirement.txt, everything will be installed. So now let me hit enter, and it will start installing. Okay, it will take maybe 1 minute or something. So what it is telling, you should consider upgrading. So okay, let me upgrade pip. So you can run this command basically. Okay, and now you can run the previous one. Okay, so basically why it is not installing, I was wondering basically, but here you see this white dot. Okay, I have not saved this requirement.txt file, so indirectly nothing exists inside that one. So basically if you just save it, and now if you run it again, okay, so now if I run it again, it will install. Okay, so it will start. Now it is installing the libraries. Okay, so it will take some time, so let it install. So one by one, every library is getting installed. Okay, and meanwhile it is installing, I will just create some more file here. So basically I need one app.py file. Okay, so that will be your main file where I'll be writing the complete Streamlit related code. And then I need one more, for example, for RAG related functions. Okay, so everything around RAG architecture, whatever I've explained. So for example, what component it has? It has a retriever component, it has a ranking component, it has generator component, right? So I'll be creating a class, and inside that I'll be creating a method for all these things. Okay, and before retrieving, of course, we need to extract the data from that blob. Okay, so I'll be creating a load data method. Okay, and then I need to split that data. So for that I'll be creating a split data. So all these methods I'll be creating one by one. Okay, so no need to worry. So see, it is installing, and meanwhile it is installing, I will just write some code here. So what you need to do basically, as you are going to work on LangChain, you need to import certain libraries. So I have noted down again, so I'll just paste it here. So for example, let me explain. So BS4 is beautiful soap for like extracting the text from that blog basically. Okay, and again, LangChain have for prompting purpose. So from here, I'll extract the prompt chat OpenAI. So here I will be extracting the LLM model, web-based loader. This is again, it will go with the beautiful soap for extracting the, text OpenAI embeddings. It will be used for generating the embeddings. This is normal string output parser, then recursive character text splitter. So this will be used for text splitting in the character, and then this is a chroma DB, and then runnable pass through. Then again, using runnable pass through, you can pass the existing values, or you can just add the keys at the runtime. Okay, so you will be using this, then you will be more clear. Okay, so these are the libraries, and one more thing, basically, so I need to load the virtual, not virtual, basically the environment variables. Okay, so for that we need this load.env. Okay, so for that here you need to have a .env file. So from that it will refer. So I'm going to create a .env file. Okay, so I'll just put the content in a minute. Okay, so here from .env I'm importing load.env. Okay, and then what you can do, basically, you can just do. Okay, so it will load it. Now here you see like everything is installed, and now if you go inside your environment and inside library, see everything is installed, right? Okay, so everything is got installed, so well and good. And now we'll start. So now, as I said, there are two important py file. One is like rag.py, and another is like a app.py file. In app.py file, I'll be writing the mostly the request related code, where I'll be generating the request, and for business logic, I'll be coming here in rag.py. Okay, so in rag.py, as I said, what we need to do, basically, there are certain steps. So load data. Okay, then we need to split data. Okay, and then what you need to do, basically, you need to store in VectorDB, and then you need to retrieve based on query, and then you need to generate. Okay, so these are the main component, basically. So against that, we are going to generate the methods. So no need to worry. Okay, each method will create one by one. Okay, so for that, how we can start, basically, we need to create. We need to store the data embeddings into the VectorDB. For that, we need a path. Okay, so for that, we can generate path underscore vector store, and that we can give maybe VectorDB. Okay, this is the path. So for that, in that path, so that path should exist. Here we can create a folder. Okay, so using the same name, VectorDB. Okay, so now it got created. So now don't get confused. Like, so everything we have created just now, right? So everything. So VectorDB just now we created. This is a virtual environment, and inside this we are going to keep our that secret key. Okay, and these are the two main file, and this is the requirement file. Okay, that's it. And now let me create a class, and we'll give it as a rag model. Okay. And inside that, we need to create various methods. So the first method will create kind of that constructor, basically. Okay, so we just defining init, and so this is the basic Python programming. Okay, so I'm assuming basically, so I'm passing the self object here, and using that we'll be calling the further method. So as I said here, I'm going to create load data method, I'm creating split document, then vector store, then retrieve. Okay, so these are the method I'm going to create. Okay, and before that, I also need to, okay, so let me start with that one. Okay. So what we can do, basically, I can create def load. So what you need to do basically in that load method. So let me show you here. So load data. Okay, so here what you need to do, basically, you need to provide the path of that blog, basically. Okay, so you can keep here any website path on which you, or any repository path where your data is, basically. Okay, and then what I'm going to extract, basically, post content, post title, and post header. So these are the three things I'm going to extract. So that's what I have defined here. So this is the syntax of beautiful web-based loader. Okay, that's nothing else. And then whatever data will be loaded, so I'm storing in doc. So this is the variable. So using self.ops, I'm just storing everything here. Okay, and if you want to just print, basically, so what you can do, you can simply write the print statements, and you can just do the printing. Okay. So next method, what you need to do have basically split document. So we got the document. Now we need to split them. Because why we need to do splitting, basically the reason is like a document could be very lengthy, and then storing and then searching and then similarity matching could be a challenging work. So that's why it's always advisable you need to create store data set into the smaller chunks basically. So that's where next part is split document. What we are going to do basically here, I'm using a recursive character text splitter. So here, as you see here, I have already imported this library. Let me minimize this. Okay, and then that I'm using. So here I'm defining chunk size. So chunk size is nothing but like every chunk will have 1000 character, and there will be overlap of 200 characters. See, important thing is here like overlap. So basically I'm overlapping 200 character in every chunk so that it doesn't lose the context, right? If I'm not overlapping, then there are chances it will lose the context. And at start index, basically it will start the index of that particular character. Okay, so this is how you can define this text splitter, and then finally you run the text splitter on the docs. So whatever docs you have created in this previous method. Okay, so I hope these two methods are clear. We have loaded the data, we have splitted the document. Okay, so let me create first, then I will execute, then you will see. Okay, because individual document I cannot run basically. Of course, so you can run individually in different chunks, maybe in notebook and all. Okay, but here let me create the whole things so it will be more clear. So now here we have splitted that data, and now we need to store into the VectorDB, right? So for that we need to generate embeddings and everything. So what you can do basically here, create another method. So that is store vectors. So here, so these I have commented basically because these I have imported at the very top. Okay, so what we are doing here from from documents. So here documents is our like self.split. So here we have splitted the whole documents into different splits basically. Okay, if you just print here and just apply length, that is the length basically. Okay, so you will get to know like how many splits are there. And then embeddings, so I'm using OpenAI embeddings. Okay, and then persistent directory. So here you need to give the path of the vector store. So just I have defined this one. Okay, you can give this path. So make sure this path exists. Okay, so now whatever embeddings are getting generated, so those will be stored in this VectorDB path. Okay, so right now there is nothing inside this. Once I run, so it will work. Okay, it will, you will see there is something there. The next I have generated the VectorDB. Now next we need to create a retriever method, right? So what you can do, we can define a retrieval. So here again retriever, so I'm using like self.vector store. So vector store I have created here. So vector store contains the reference or object of this VectorDB, and from that I can do .as retriever. It will start retrieving the content based on the query. Okay, so here I have written search type is equal to similarity, and how many documents we want? 6. Okay, six top most document that similar 6 top similar documents. Okay, so this is what your retriever method will do. And then what we need to do, basically the next component is like generate. Okay, so what here you need to have a generate method. So let me define generate method as well. Okay, so this is the most important method basically. So that's where here you will see a lot of code. So let me remove the unnecessary code. I was experimenting something, and that's where like I had this lot of code. Okay, so no need to worry. I'll just explain everything. So here basically in generate, what I'm doing basically, I'm creating a reference for LLM, that is a large language model. So here from chat OpenAI. So from OpenAI, I'm using this GPT 3.5 turbo version model. Okay, and temperature on 0 means like it will give the most deterministic response. I have written here for your later reference. Okay, and while if you define as 1, so it will produce, it will still be a correct, I mean near to correct response, but randomly generated. Okay, but this will be the most accurate one. Okay, and then here next is like I'm just formatting the documents. What this is doing basically, whatever is there in the page content, like so there are different docs. So here you will return 6 docs basically. Okay, and for each doc there will be a content, and that content we are combining based on the next line. Okay, so that's what being returned. So no worries here. So and then here, so as I said, prompt. So here from the hub, that Hugging Face hub, we are taking this RAG prompt. Okay, and if you want to see how it looks like basically, so you can simply uncomment this, and you can see the like how it looks like. So maybe I will just show you. I am just uncommenting here. Okay, so here we have context and question. Okay, so context will be returned from this retriever, and then we'll have a question. Okay, so both are combined with the prompt, and then that prompt will be passed to the LLM model. Okay, and now here I'm defining rag chain. So what rag chain will do is here I need retriever, and important thing is here these pipe symbols. So pipe symbols are nothing but here in this chain methodology, basically the output of this previous step is passed as an input to the next step. So this is what pipe symbol will represent here. That's the logic behind this pipe symbol in chaining. Okay. So here, whatever retriever context retrieved, we have retrieved from this VectorDB. So that is passed to format docs, because this, as you see here, this is returning 6 different documents, right? And those documents I am passing in format doc method, so that every content of that document is combined in one string based on new line. Okay, and then we have a question, and then everything is passed to the next step. Okay, and then we have a prompt, and then we have LLM. So prompt we have anyway defined here like this, and then LLM we have defined here. Okay, and then string output parser. Okay, so ultimately it will generate a string basically. Okay, and then what you need basically here so this request. So in this request basically whatever see here. So here, whatever string you type, that will come in the in terms of request basically. Okay, in the object of request. So that code you will write in that app.py. That's what we have still not written. So I am just right now defining the kind of business logic, the everything backend. Okay, around RAG architecture. So here basically what you will do based on whatever request, whatever query is, okay, so that will be passed in ragchain.stream. So stream is like character by character it will go. Okay, so stream in the streaming methodology. Okay, so that request will be passed in this chain, and then it will return the ultimate response. Okay, so that's where like if I just go back to this one, so here you see, right? So we have LLM here, okay? And then here we have prompt plus filtered document. So this is nothing but coming from retriever. Okay, so here in our case, we have defined k equal to 6. So 6 documents will come here, okay? And along with the combined with the prompt, then those 6 documents combined with LLM will generate the final response, right? So that's what is happening here. So we have prompt, we have LLM model, and then we have that retriever 6 documents, okay? And ultimately we have combined them into the strings, okay? And based on that, this RAG chain will generate the response, and that response again we are kind of, it will be in different chunks, and we are just kind of combining, and then at the end we are just you can like how to define the end, like you can press this comma or dot or empty string, okay? So basically, and the end character, okay? And then here, so this way it will print the result in command line, but we want to send back, so that's where I'm returning here using. So here every chunk I'm joining with this empty string, okay? So here every chunk is like kind of the one response, like uh, with dot, okay? So one string basically. So okay, so it will be the combination of multiple strings. So coming from different documents, whatever retriever has returned. Okay, so these are the whatever we have done basically. We have loaded the data, and so here let me explain here. We have loaded the data, we have splitted the data, we have stored in VectorDB, and then retrieved the context based on the query, and then generated the response. Okay, this whole thing we have done. But how to call these things, right? So that we have still not defined. So we'll define a callable method here. So that's where you see here every method is being called, but I have not called the generate method. So I will be writing a callable method here, which will call the generate method. So that's where here, okay? And from that, I'm passing this request, okay? So this request will be passed to the generate method. Here you see request I'm accepting as a string, and based on this request, this is passed in the RAG chain, and then whole response will be returned, okay? So this is the whole logic of RAG, but we have still not executed, okay? So now let me quickly build a simple UI on top of that. So for that, what you can do basically, okay? So we need some Streamlit, because I'm going to use Streamlit. In my previous video where I have built another question and answer system using large language model, okay, there I have used Flask for like adding the web interface. Okay, so if you want to use Flash, you can use that one as well. But now Streamlit is getting a lot of momentum, so I just thought we can use Streamlit here. Okay, so here what I'm doing basically, I'm just importing Streamlit as ST, and then Streamlit chat I need, and then we need some components to like the UI component. Okay, so kind of container. Okay, so that's what I'm using this one. And then from this rag, so this is the file rag, I'm importing rag model. Okay, so inside that, this rag model is a class, okay, that I'm importing here. So now let me define some method here. So what you need to do basically, I'll explain again one by one. So here basically I'm just defining an initialize rag model method, and inside that I'm just calling this rag model. Okay, and then I'm just writing st.cache resources. So what it does basically, I have written here so that you don't forget for later reference. So this is the decorator to cache function that return global resources. So for example, as I said here, so if you just go to rag.py here, from I'm loading the environment variable. So I have still not defined because this is a confidential. At the end only, I will just put the secret key here. Okay, so no worries, but assume there is a secret key here. Okay, so how it will look like basically. So anyway, I'll just change this secret key, so no need to worry. Okay, so this is the secret key, and now I'm just loading this from into the environment variable using load.environment. So that is one thing. So anything, any variable related to model and database connection or anything, okay, which you are initializing inside rag model. Okay, so that's where what you can do st.cache resources, so that I mean, if you are running multiple times this app, so every time it will not load, it will keep in the cache. So that is the logic behind this decorator. Okay, I hope this is understood. So now next to what I will be doing basically, I will be creating another class here. So wait. So here I'm creating a rag Streamlit application, as I said. So backend I have already created in rag.py, and now here I'm kind of creating a front end and how to handle the HTTP request. Okay, so that here I'm just creating a rag Streamlit application and initializing a constructor, and then here I'm just calling this method basically. Okay, which will be connected. I mean, which will call this rag.py in the backend. Okay, and then I'll define some more methods basically here. So one important is like generate answers. So what this generate answer will do basically here. Okay, so here now let me open this so that you can correlate. So here I will be passing this query. Okay, so this query will be directly come in this st.session.request. So this will hold that query from the front end. Okay, and I'm storing that into the request method. And then as I said, I have a spinner, so kind of for progress, showing progress. So that's where here st.spinner. So whatever you write here, so the moment you hit the query, this one. Okay, so at the top you will see the wait sign. Okay, so that is coming from that part. Okay, and then here response self.rag model. So here I'm calling this rag model. Okay, so I've already initialized here. Now it is available in this self object of the class, and then from that, if I pass the request, then it will call this rag model, and from there it will be connected here. It will directly jump here, and it will call the generate method, and then internally everything is linked. Okay, so that's what will happen. So now this will call. So here I have written a response again. For example, if you're testing something and you don't want to hit the API back and forth because you have a limited responses, a limited hit you can do in the open API. So you no need. So for that, if you're testing, so you just simply comment this and uncomment this so that you're not hitting again and again. Okay, and you can test your UI part. Once everything works fine in the UI, then you can comment this part and you can uncomment this part. Okay, for testing purpose. So that's fine. And then what I'm doing, so I got the response. Okay, and then st.session st.history.append. So here basically I'm maintaining the history. So what is the history basically? So that if I'm asking multiple questions around the same topic, then this whole, for example, this what is adversarial attack, how adversarial attack impact output of the model, this whole thing is maintained as a history in that dictionary. Okay, so that's where we are maintaining a history, and here I'm appending the message. So this is the user request, that is the user query. So that's where is user is equal to true, and response is coming from the bot, not from the user. So that's where this is the false. Okay, so in session state I'm maintaining this history. So this is so now we got the the answer part. Okay, so this is one thing, but we need to initialize the app as well. Okay, Streamlit app. So for that, we need to have one more method, like we'll just define one more method. Okay, run app. So what it will do, basically, it will initialize the app, and let me just paste some more code. Okay, so basically what I'm doing here, so now if you again see, so there is a container, so this is the border box. Okay, so here I'm defining a container so that every response and query is put inside this container. So for that, what is the block of code? So with st.container, I just put a border is equal to true, and here I'm just checking if history. So this is the key. If this key is available in session state, I'm sorry, I'm doing not. Okay, if this is not available, it means we need to create a blank dictionary. So that's where here dot history, I am initializing it with empty. If it is available, then no need to do these things. Okay, and then what I'm doing next, so enumerate, so session state dot history. So here I have already created the history. If it is the first time, then only one query and response will be there. I'm just enumerating on top of that, and then st dot message. So st dot message is nothing but this is this will generate a chat window here, kind of. So it will generate this message. Okay, so that's where in the chat and key. So with key like that whatever response ID 1, 2, 3 like that. Okay, so it will do that thing, and it will simply print that one. Okay, and now st.text input. So this is nothing but this is the text input of this where you write this query. So like this one. Okay, so here this is that part. Okay, so this is basically the simple fundamentals of a Streamlit. Okay, so that's like you can just go through more about a Streamlit. So here using Streamlit, we can create a text input, and we are not now giving the default text, so that's why it is empty, and key. So whatever you will type, so that will be attached to the key as a request, and that's where using that request key here you are able to get that query, right? And on change, so it will just if you do the on change, it will just trigger this generate answer method. Okay, and then there is a clear button. So here clear, if you just hit the clear, then it will just erase the history. Okay, so that's what this is doing. Okay, so now if you see, so we have generated the run app, but we need to have a main method, right? So we can create a main method here. We need to do the indentation. Okay, and what is happening? Okay, so this will be outside. Okay, so now we have created a main method and then main block basically, and then inside that I'm just initializing this class. Okay, so instantiating this class, and from that class object I'm calling this run app method. Okay, so this is the first one we will be called, and inside that this will call generate answer, and this generate answer will call this rag model, and from that rag model it will come here, and this will land to this callable method, so generate, and then from here this generate will come here, and then everything is linked. Okay, so now every block of code is being written, and now I hope everything is perfectly set up, and now let me run. Okay, so how you run? So now you see at this part in my terminal. Okay, I'm just typing Streamlit run app.py. Okay, and I hope everything is set up correctly and it will work. So let me run it. So now you just focus in the terminal. Okay, what is happening? So here it will create a VectorDB as well. Okay, so that's where it might be taking time. So it is running first time, so it will take some time. So let it run. If there is some error, then of course it will display. We'll see. We'll tackle that one as well. Okay, so now it is running. So what is happening here? So if you see this window, so here it is coming. So you see here, right side, it is running, right? So let me see. So it is saying, okay, initializing rag model. It is initializing the rag model, and let me see if it works. Okay, so now if you see here, so it is saying, okay, yeah, it is running, and this is the URL which you can open. Okay, so using this URL, you can access this application. So that is fine. Okay, so now if I go back there, so now you got it. Okay, your personal GenAI assistant. Okay, and if I show you, this is the title I have written here. So if you just come here, yeah. So in this, so inside run app, I have given this your personal GenAI assistant. If suppose I'm just changing this, okay, I'm just putting more exclamation sign. Okay, I'm just saving it. Okay, so now if you go to UI, and you will see, okay, source file change, you can rerun. So so now here you see one exclamation sign is there. I'm just running, so you see it is immediately reflecting. Okay, and now if I ask, okay, explain me what is adversarial attack. Okay, and now I hit enter. So what it is telling, okay, could not import LangChain have, please install LangChain have. Okay, so I forgot to install this, so no worries, so we'll install this. Okay, so let me stop it and pip install. Okay, so I'll install this, so it will install. Okay, so it got installed, so that's fine. And here also you see left side menus like in VectorDB. So in VectorDB, this VectorDB is got created, and inside that embeddings are stored. Okay, so that's fine. And now let me run it again. So now if you see here, so it is running now. Okay, now if I ask, okay, explain what is adversarial attack, and hit enter. Okay, so let's see. Now it's, you see here progress bar is appearing, and here in bottom you see the terminal also, right? Here this terminal window. So now you got the answer, right? So perfectly it is giving us the answer. And if I ask, okay, some other question, so maybe you just go to that blog and you see like what other questions come from that adversarial attack. So types of adversarial attack. Okay, so let me ask, what are the types of adversarial attacks? So let me ask next question. What are the different types of the adversarial attacks? Right? Let me see if it is answering correctly. So it is in progress, right? It is generating the response, and here you see in the bottom. So now you see here, the different types of adversarial attacks include black box attacks, attacks on generating models, and attacks on model training process, such as data poisoning. Adversarial training is a common defense mechanism against these attacks, but it can lead to a trade-off between robustness and model performance. Like, so it has given these different types of attacks as well. Okay, and it again depends. Like, I have trained this on in only one block data, right? So you can increase the data size, then there will be more accurate responses, right? And you can define the prompt differently, so that it can format these answers differently. Okay, maybe in listing and all those things. Okay, so here I'm not going to cover prompting in detail, because that is itself a huge topic. So in next video I'll be explaining prompt in detail. Okay, now let's talk more about this GenAI assistant, what we have built now. Okay, so now you see here like these box is at the bottom, and this clear. Okay, so for example, if you clear, then this whole chat will be cleared. Okay, so that's fine. So for example, if I am clearing this, okay, and then I'm just running this again, enter. Okay, so now it will just remove this whole string, and it will give only one response, because history is being cleared already. You see here, right? Now we have only one answer. So that's how you can play around with this, and there are many things to play around basically. Okay, and what else remaining? So let me see. Okay, so I was just playing around a few things, so it is nothing. So what you can do basically. So for example, here these answers are getting generated. Okay, so for example, if I ask, okay, what are the threats in adversarial attack? I'm just typing random questions so that I just get the second response. Okay, and it will just append at the bottom here, okay, after this response. But you know what happens, like Streamlit is still like advancing, okay, it doesn't have that much flexibility as we have in Flask or HTML, okay. You can write HTML code, that's fine. If you ask one more question, then you won't get a scroll bar here. Scroll bar will come here and your text box will be hidden. So for that, what you can do basically, you can just remove this. What you can do basically, you can put this particular box at the top here, okay, just after the title, okay. And then also what you can do basically, you can just comment this part, okay, and then you can just do the uncomment this. What it will do basically, it will generate the reverse. It will just reverse the history. So what I meant here basically, so if you just refresh, so this block will come at the top, and then the latest answer will be at the top. So old answer will go at the bottom. So let me refresh this part. So if I ask what is adversarial attack, okay, so let it process. Okay, so it is still at the bottom. Okay, I will just see, but let me just ask the second question. Okay, so that if I see, okay, it is reversing or not. So different attacks in adversarial attacks. Okay, so now I'm expecting this answer will be at the top because I have applied reversed. Okay, so why it is not happening basically? So it is I need to rerun this because it is not taking it properly. Sometimes there's a cache problem. Okay, if I rerun, then it should work basically. Ideally, it should work. Okay, because I have just, oh, my bad. I have not saved this, man. Okay, I need to save it. Okay, so but anyway, it will work. Okay, basically, let me rerun and show you. I have not saved that part, so that was the reason. Okay, so now it is again reinitializing. So now if I ask what is adversarial attack, so now you see, I'm expecting the answer to be at the bottom here. This text box will remain at the top. What I did. Okay, so this is a rate limit search for, so as I said, okay, if you keep on hitting the APIs, you will get, after a certain time, you will get the rate limit is reached. So that was the reason I was telling, okay, just comment this part. Okay, and just uncomment this part, because now I'm just what we are doing basically, we are not doing anything. We have already seen like how LLM with RAG worked. Here I'm just playing with some UI stuff, that is Streamlit stuff. Okay, so I just saved it and then again open this and refresh this. Okay, and see what are. So now you ask anything, okay, it will have a fixed answer because I just passing the fixed string as a adversarial as a response, right? So it doesn't matter what you write here. So see, so my objective was to show you like this will come at the top and this answer will come at the bottom. Okay, and now if I ask 1, 2, 3, some more question, okay, suppose, then this will be appended at the top. So old answer will go down. So if I just type 4, so like that. So latest response will be at the top. And if I ask I write something more here. Okay, so then the latest response will be at the top, and then older will go at the bottom. So this is just a Streamlit thing, right? So you can just play around with it. But I hope ultimately you got like how RAG works. So if I just open this architecture again, so what we did basically, we had kind of that blog post. For that we have generated the embeddings and stored in vector model. Okay, and then what we did, we had a query, okay, what are adversarial type. For that also it will generate the embeddings. It will go to VectorDB. From there it will search against that embeddings like the query, and it will retrieve the context. That if we have defined the 6 documents, it will extract the 6 document, and then it will attach like combine with the prompt, and that will pass through LLM, and we are using that Turbo 3.5 model, okay, from OpenAI, and along with that it will generate the response. So this is the whole architecture, and that's what we have implemented as well. Okay, so I hope and here it is generating the VectorDB. Okay, so I hope app.py, rag.py, everything is clear to you. But if you have any doubt at any place, just comment me and I will try to answer. Okay, and that's it for today's video, and I hope you have enjoyed this. And if you are liking my videos, then just hit the subscribe icon and hit the notification icon, and don't forget to share within your community, so that I mean, it will reach to the more audience, and that will help me as well. Okay, so thank you.